Okay, I think we have most people already, so we'll just go ahead and get started, and others can join as they come in. And thanks everybody for today for joining. Exciting, it's week 3 already, Saturday, the 21st of November, and I hope we are having fun and we're learning new stuff and working through the project. Before we start in the lesson today, I would allow Silva to give us a minute or two, talk about maybe some support on resume and other things that she has to share with the group before we can hand over to our instructor, Vishal, to continue the lecture. So with that, I'll let Silva go ahead and give us some insights.
Thank you, Michael. Hi, everyone. It's actually nice to see you all back here again virtually. I am super excited. This is week 3. Can you all believe that? I mean, like, since we started up till now, and all thanks go to Michael and Vishal. I appreciate it's not so easy putting all this together and having to carry everyone along. Thank you so much, guys. And I want you guys to give them a virtual, is it hi or a virtual clap, whatever it is, just to say thank you for all the support and for what they are doing. Just sending high fives, virtual clap, whatever it is for both of them. Um, we appreciate what you guys are doing. Thank you so much. Yeah, I just wanted to say, yeah, let's keep it coming. Let's keep it coming, please. Thank you. Let's say thank you to for what they've done. I mean, and for you guys, is your participation have been all superb. I appreciate this is really going on so well. Thank you. To also add to that, yes, let's keep it coming. Okay. Thank you all for sending your appreciations. Thanks, we appreciate. Also, to add to that, I wanted to say if anyone needs resume support, needs an eye to look into the resume, or if there's any help that you need with your resume, that you should please let me know. I'll send my email. Just send me your resumes so that we'll take a look at it and give you feedback with your resume. Or if there's anywhere that needs help or anything that needs help, we'll always reach back to you and give you a feedback on your resume. So if you need resume support to write your resume or to take a second look at it, you should please, I'll say, put in my email address right now. Send me your resume through the email address. And the last week, we're going to be going through like giving feedback on email, feedback through your email on resumes that we have. And we might also have someone come to talk to us about Python and what benefits we have learning Python, the jobs that are out there, interview questions, and how you go about the interview questions. So that's a little thing I wanted to put on today. Thank you all for all your participation and for the instructors for what they've been doing. It's been really great. We're super excited about this, and we have more courses coming soon. And in summary, if you need help with your resume, just email me your resume. The last week we'll be talking about um, giving feedback on resume and telling you the benefits of learning this language and what you can do with it and how the interview questions are being asked and possible answers. Thank you so much. Let me pass it now to Visha and Michael.
Thank you, Silva, for that insight. So she'll send her email address so that you can send your resume and questions you have and just career guidance in general, and we'll be able to provide responses. With that, Vishal, I'll let you take it from there. I know we have a lot of material to cover today, so I'll let you get going with week 3.
Thank you, Michael. Thank you, Silver, and thanks everybody for those comments on the chat. I was just looking at Philip's comment. He said, "Thank you. I don't know where my emojis went. I actually read it. I don't know where my emotions went. So I hope your emotions are still intact. The emojis can come back and forth. That's okay." So yeah, exciting week this one. We're going to have more visual stuffs in here. It's not just coding. We will see some plots and everything. But before we start on with this week, just a quick recap. We have come a long way. It's been like, almost past the halfway mark, and we started off from really basic. We came up from a place where we uh, we introduced Python, and we looked at basic data types, we looked at basic Python functionalities. Then we started making it more and more complicated by introducing like Pythonic objects, like lists, dictionaries, and things like that, tuples and all. So, and then we started using them more, right? So we had more specific libraries that we looked into. We looked at NumPy, we looked at SciPy, and stuff. So we looked at, or not SciPy, we just looked at pandas rather. So um, yeah, so we introduced things like a NumPy array, or a pandas data frame. And we last week, I think, we looked at a lot of manipulations using pandas and NumPy. I hope you guys appreciate that, both these packages are super specific to the utilizations that you might have, or the problem statements that you might have. And it's always a great thing to know about these libraries based on the functionalities, and also based on the problems that you have. You might be more more familiar with one particular package versus another, but that's okay. That is, I think, part of this whole learning process. So without much ado, we will start off with this week. So let me share my screen. Michael, I hope that's okay. Did you want to share something, Michael? I see
No,
your screen. Okay,
yeah,
all
go
right.
ahead. Sure. Yeah.
Okay, all right, perfect. So please let me know if you guys can see my screen. And hopefully it's coming out clearly. Can somebody give me a quick thumbs up or anything? All right, perfect. Yeah. So we have been using Google Colab for all of our work, right? So that was another introduction into this course that, I mean, maybe some of you might be familiar with, but this was something that we are using for this particular course. And it just has all the virtual capacities of a virtual machine. It's almost like a Amazon Web Server, or the Google Cloud. It uses Google Cloud or Microsoft Azure. So today we will start off with the data visualization. So let me actually insert a text box in here and say that this is the introduction to data visualization. And we will look at one particular package in details, which is the matplotlib package. And we will do a lot of operations using matplotlib, and we will plot different stuffs using that. But I hope for some of you guys who were here last week, you might remember that we also introduced the Seaborn package. So the Seaborn package is also something that we will touch upon again today. And that's also another plotting package that we have. All right, so matplotlib. So let's actually go to the website for matplotlib, and it is essentially matplotlib.org. That's the name of the website, and this is how the package looks like. So it's a comprehensive library for creating static, animated, and interactive visualizations in Python. So this is a very powerful statement that they have as their opening line, right? So it's not just static animation, it's not just static plots rather, which is like plots that you make and you can export, and then use them in your PowerPoints or reports or whatnot. But you can also make animations out of this. So you can create animation. It's creating frame by frame, combining those frames into a movie. You can do that. And also you can create interactive visualization, again a very powerful way of utilizing the plotting to visualize things, especially in different problems such as data analytics problems, where you're trying to, let's say, test how in a particular equation, if you change a particular value, how does that change the plots and stuff like that. So it's pretty interesting. I'm hearing a little bit of an echo in the background, so if you guys do not mind, can you please mute yourself? Right, thank you. All right, and yeah, feel free to ask me questions mainly to the chat, and we can. I mean, if you have a burning question, you can definitely come off mute and let me know. So, all right. So what we will do now is we will use Matplotlib library for visualizations, right? So Matplotlib has a lot of packages inside it, and we will mostly look at the module or the package called PyPlot. So PyPlot is something that is inspired by the visualizations that's in there in MATLAB. MATLAB is another software. Some of you might be familiar with it. So it had very good visualization and became very, very popular, especially in the scientific community because of its power, not only in computations but also creating very nice plots. So this package PyPlot was introduced into Matplotlib, and that was essentially to replicate some of these plotting capacities that MATLAB had. So and that actually came a long way right now, and has established some of the things which even I think MATLAB cannot do, or like it's as good as MATLAB. You can do almost everything that you can do in the plotting as you could do in MATLAB using PyPlotlib. So PyPlot is the package which we would use. So let me actually make a note of. Can you guys hear me? I think I lost connection for a bit.
Okay, we can hear you now.
Yes,
Okay,
yes,
okay,
yes.
perfect. Yeah, sorry. Bad network quality. That's not good. All right. No, I hope my network behaves. PyPlot. All right. Okay. So as you guys might remember from before, we import different libraries using the import function. So we'll use the same. So you have to do one extra step, and this was something that I mentioned last time as well. Maybe some of you guys caught note of it, but to make sure that the plots happen in line inside this Google Colab notebook, you do have to add an extra line which actually helps you or enables the functionality of plotting inline, or else it would go off the screen, which is another way of doing the plots. But the power of Jupyter Notebook or a Colab notebook is that you can keep plotting inside the notebook as itself. So the first thing that we will do is we will say import. And Matplotlib is a pretty big library. So we, like I said, we will use the module called PyPlot. So we will say import matplotlib.pyplot as PLT. So this is, we're going to use a lot of plotting, and this is kind of.
I think we lost your screen share.
Oh, you did? Oh, sorry. Okay.
I can see your screen though.
Oh, okay. I'll reshare just
Okay.
just for everybody's sake. Okay. All right.
Can we all see it now?
Yes, I see it now. Thank you.
All right.
Okay,
Thank you.
problem. Yeah. So we're going to import the PyPlot module from Matplotlib, right? So we'll say import matplotlib.pyplot as PLT. This has again become a standard in the Python programming world to import the PyPlot module as PLT. And the next line is where we will specify to plot inline in
I think we lost him again. Network. So let's give him a second to reconnect.
Can you guys hear me?
Yeah, we can hear you. We lost you briefly.
Yeah, sorry about that. I don't know what's happening. I do. Yeah, it should be connected. I'm not sure. Sorry about that. Technology. Uh, bad network quality. Okay. Can you guys see me and okay, rather see my screen and hear me?
Yep.
Okay. All right. Perfect. All right. So so that's like, as you guys know, it takes a few seconds or a minute to get the virtual, machine. It's connecting now, and I hope we'll get the machine soon. Yep. So we are getting the machine with, and it's connected. All right. So now we have imported the matplotlib library and the specific module pyplot inside the matplotlib library as PLT. Now we're going to use some of the things that we discussed upon in the previous lecture. So I'll import NumPy and pandas as well into this notebook. So this should be a revision for you guys. So I'll import NumPy as NP, and I'll import pandas as PD. Okay, I'll run these two notebooks. And then remember last time we had a nice data set that we were using for a lot of our analysis. This was the iris flower data set. So I'm going to use the same data set. So hopefully you guys have the link for the data set. If not, I'm going to paste it as well in this in the chat box in case you guys want to use it. Let me copy paste that. So yeah, you guys will have it in your chat box. So we use the read_csv file to specify the address or the file name. We do it inside the single quotation mark, and this is the data set. And because we are using pandas, it's going to import it as a pandas data frame, right? So let's see. Yep, this is how the data looks like. This should be again a revision for you guys. Remember, if you do not want to see all the data set, we would use the .head function to see the first 5 columns, right? So, but we, or 5 rows rather. So, but we have 150 rows and 5 columns in that. All right, so now we have a data set which we can use for our examples to plot, right? And we'll start with the simple 1D plot. Okay, so we'll try to plot how this sepal length looks like when we plot it, in a simple 1D plot. So our first plot, simple 1D plot. All right. So the way to do this is essentially you will call the matplotlib.pyplot, which we named as PLT. We will call that particular function. We will use the dot to access what's inside the function, and then we will use a thing called PLOT. Ataiku, if I am pronouncing your name correctly, I think you're going off mute. So I'd appreciate if you can mute yourself unless you have to say something. Yep. All right. Somebody said they missed the line after iris. Okay. So I have this as the pandas.read_csv. I imported the iris this particular CSV file as the iris variable, and then I used .head. Again, remember this is from pandas class, so we could use the .head function to look at the first 5 rows. And if I did not do .head and just wanted to look at what the iris data frame is, then I could just put iris, and then it would show me that it has 150 rows and 5 columns. All right, so after we did this, now we have a data set that we can use for plotting. So we were looking at our first plot. So the way to do this is you need to call this the function that you have imported, PLT, and then inside it or the module that you have imported, PLT, and inside it you know this is again standard Python programming scheme. So we use the dot, and then we'll use something called PLOT, plot. So that actually helps you to plot you know, different 2D plots, so X and Y you can. But here in this case we will just use it to plot a 1D plot. So we have called the function plt.plot. Then again a standard Python scheme of specifying things inside a function, right? So we open and close the first parenthesis, the first brackets, and inside this we will have to specify the variable that we are trying to plot. So let's say we are trying to plot the sepal length from this iris database. Now again, this must be a revision for you guys from the previous class. So if we have to extract a column from our data frame, we use the name of the data frame, and then we use square brackets, and then we specify the name of that particular column, right? So, and that's it. You do not, if you want to have the simple plot with the default settings, this is all you need to do. And if I run this cell, it will show you the plot of the sepal length. In the x-axis is the number of rows, so you're going from 0 to 149, and in the y-axis you have this particular sepal length plotted. Let me see. So somebody asked me, are you sharing your screen? Can you guys see my screen? Sorry, this is getting a little bit confusing.
Yeah, I can see it.
And can you hear me?
Yeah, I can hear you clearly. It's unique to.
Okay. So all right, so hopefully you guys have the first visual plot using this iris data set. So again, in the x-axis are the row numbers, and in the y-axis is the actual variable that you are plotting. So now let's do some fancy stuffs, right? So what we will do is that, you know, in a lot of cases, especially like in our case, let's say when we you know, plot different. So in geoscience there is always a plot of well logs. So we try to invert the y-axis, so meaning that, you know, you are increasing in depth, right? So that can be one example, and there can be several reasons why you want to do that. So let's say for some reason the person who you are presenting this plot to is more you know, adept with the situation where they see the y-axis you know, not increasing from bottom to top but decreasing from bottom to top, right? So we want to invert the y-axis. So these are, I'll show you some of the many functionalities um, of the matplotlib function. All right, so so I'll put a comment in here, inverting the y-axis, right? So that's the axis with the sepal length values, right? So what we will do is that we will copy this line because we need to plot it first, right? So plt.plot, and then we say iris sepal length. That's our variable. Now, in order to do all these operations like, you know, inverting the y-axis or, you know, setting limits for the y-axis, x-axis, it's a way of doing this is to get the handle of this figure, right? So this is again a terminology that's coming from MATLAB and MATLAB's plotting function. So we are trying to get the handle of this plot. And in order to do that, what we use is we use plt.gc Okay. So it says gets the current matplotlib axis.axis instance on the current figure. So this lets you get a control of the plot that you have in here, right? And then inside, once you have this control of the plot, once you have the handle of the plot, then what you do is you do dot invert underscore y-axis. That's the function, right? So that actually helps you to, you know, invert the y-axis. And you could have said that, oh well, I mean, I could have done something separate, different, you know, there are different ways of doing this, but this is possibly one of the simplest way of inverting the y-axis. So now again, difference between the previous plot and this plot is that here the y-axis is decreasing as you go from bottom to the top. Okay, so I have a question here. Can you explain what the hex number is above the plots? So you see, like, you know, this is again something common to other, you know, Pythonic objects or Python related programming that happens. So you could actually write these plots to a variable, right? So if I say that this is equal to plot1, and that's a variable, then this particular thing would not come out as an output. So if you do not specify a variable, it gives you, you know, the address of of this particular, you know, plot that's happening. So let's actually try this. So we'll say plt equal to this. So yeah, now actually you have saved the plot in a variable as well. So you could do that, and there could be various reasons why you want to do that. But good question and good observation. All right. So now we have inverted the y-axis. Let's see if we can do something more. So let's say you do not like this blue color. This is like, you know, it's a pretty not so cool for you. So you want to, you know, change the color of the plot to something which is more eye-catching. Maybe I don't know, black. Black is, or maybe you do not have a color filled like, you know, printer. You want to plot everything in black and white, right? So in this case, what I'll do is I'll change the color of the line plot from default equal to blue to black, let's say. So again, a very simple way of doing it. So again, I've copied and pasted the same line that we had before, plt.plot and the variable. And inside this, you have different keywords, and you can look at it in the help file. There are lots of ways. So let's say they have an example, plot x comma y comma b and o with blue circle marks. So this is how you know, specify the color and the type of symbol and whatnot. And there's a whole lot of example for all of this. So you can see that, you know, all the parameters that's in this plot function are kind of mentioned here. So we'll use what is called K. K is the short form for how you define black in you know, in the color library here. So K is for black, R is for red, B is for blue, and so on and so forth. So that's my same plot. Now the axis is again in the default, increasing from bottom to top. But now the only difference being that, you know, my plot color, the line color is in black. Now the other thing that you might want is, well, you do not want this to be a continuous connected line. You want this to be you know, like represented by dots or circle, open circle. So what you would do is just say okay, but it's not okay in the word okay. These are two different things. So this first character in here is the marker symbol. So it's O. You can also use something like colon that will also make some dashed lines. You can use dash dash that will also make a dashed line in a different format, and so on and so forth. So this is the first character, that's the type of line, and the second one is the color. Okay. So this is how it looks like. So it's almost like a scatter plot. But But let's go into a dashed line plot. So let me use the colon and get it to make a dashed line. All right. So now we have the basic plot. We have seen how we can change the colors and the symbol type in the plotting. So now let's add some more information into this plot, right? So what we'll do is we will add X and Y labels and the title of the plot. So Sudha is asking a question about the URL. So I did paste it here, but I'm going to paste it again for you so you can follow along. Perfect. Yeah, somebody else also pasted. Okay, so all right. So we'll use the same line for plotting, right? And we will add the X labels and the Y labels into this. Okay. So how do we plot the X and Y labels? So let's say, or rather add the X and Y labels. So adding X label, sorry, to the plot. So the way to do that is plt.x label. And again, you could do it in various ways. This is one of the ways. You can do it using the handle for the curves, and Google is always our best friend to show you different ways of doing it. But this is one of the ways of plotting the X label. So I'll say the X label is actually the sample number, right? This is like the row for the sample. And then we'll also add Y label to the plot. Right, we'll say plt.y label, and this is actually our variable, which is the sepal length, right? And again, everything that you're mentioning inside these labels, this is similar to what we learned. Like it's a string, so you could make it very complicated. So for example, if you're plotting inside a for loop, let's say if you have 10 different variables, you want to change each time, you can specify the variable name inside the labels and do all sorts of fancy stuff. So you can also use LaTeX to define few mathematical symbols and characters inside these labels. So you have all those options. You can build up from what you learned before on this. And then the final thing that I want to do is to add a title, adding a title to the plot, right? And the way to do that, very intuitive, plt.title. Let me say plot of sepal length from iris dataset. Right? That's it. So I have one line which is the plot, then one line which is the X label, one line which is the Y label, and the last line which is the title. And that's it. It's as easy as that to get a plot which is already presentable enough in any place that you want. All right. Keep an eye on the chat box. Okay, so now I'll go on to add more, have multiple plots inside one plot, right? So maybe a way to do this is that, I don't know this data set in and out, but I see two lengths. So there's a sepal length and there's a petal length. So I want to plot both of them together in the same plot and, have a legend that defines these two plots. I'll plot them using different colors and different symbols so that it's representative enough, and then I'll put a legend at the top which says that which particular plot is what. All right, so that is essentially adding more than one plot with legends. All right, so the first thing that I'll do, which is we'll use the same thing, plt.plot, right? So, and then we will say the first thing that we want to plot is the sepal length, right? And then I will plot this as a dotted line with a colon and in black color. And I will put a label to this plot. I'll say label equal to, the label is the keyword, and this is equal to, I'll put, and this is what we will use in the legend later. So whatever you want to put in the legend. So I'll say that this is sepal length, right? That's the label for this particular plot. Now in the second line, I'll add another line which plots the petal length, right? So I'll again use plt.plot, right? And I'll put iris and petal underscore length, right? This one, I will plot it in a solid line with a red color. And I will put the label equal to petal length. Make sense? And then I'll make some more information. I'll add some more information to the plot. So I'll put the X label as sample number. And I'll put the Y label as length, because we have two lengths, right? We have the petal and the sepal length. And then I'll put a title to the plot. And we'll say plot of sepal and petal length from the iris dataset. Okay. So that's my title. And then, of course, I want to also add a legend in here. This is the new thing that I didn't introduce before. We didn't need legends. So now we need legend to specify which plot is what. So to do that, we can say plt.legend. And I will just use all the default values in the legend. So, but you could customize the legend. You can make it inside the plot, outside the plot. You can make it, whether upper left, upper right, lower left, lower right. You can also specify where you exactly want it to. There are lots of handles on the legend, but I'll just use the default value for this exercise. Right, and that's it. So I'll just run this particular cell, and yeah, I think we got what we wanted, right? So we have the sepal length in the dotted line in black. We have the petal length in in the solid line in red, and we have a legend that actually describes the plot. All right, so I think there is a question. So let me actually take that. This code is giving me an error. Let me copy the code so that we can all learn from, uh, what is going wrong in this code. All right, so this is good. Import matplotlib spyplot. Dot import the data. Got it. So this is what is the problem. Yeah, so you could mention in the X label whatever you want, but you need to define the variable correctly. So thank you, whoever that person is with the email address. So there's no underscore in the sepal underscore length, right? So that was the error in here as well as here. Well, maybe not here, but in here. Okay, good. Hopefully that solves your problem. All right. So now what we will do is, instead of plotting a 1D plot, we will go into 2D plots, right? So instead of having only the sepal length or the petal length, although we have two different plots, but this was only one variable that we were plotting, right? So now we will plotting more than one variable. All right, and this is using what we call, is usually called the scatter plots, right? So what we will do here is we will use not the plt.plot function. So I'm going to introduce another function from the plt module. Um, and we will try to use the scatter function in there. So we will say plt.scatter. So that's another way of plotting plots, and this is specific to scatter plots, right? So in here we will plot, let's say, the sepal length versus the petal length, right? So we'll put in the x-axis the sepal length. So that's the first variable. We'll say iris. Within third bracket we will say sepal underscore length, right? So that's our x-axis. And then on the y-axis we will say iris petal underscore length. Okay, so this is the x-axis is the sepal length, and the y-axis is the petal length. In fact, let me actually add a comment in here. So let's say plotting sepal length versus petal length. Now, after this, what I'll do is I'll use another keyword inside the scatter function, which is the size of this marker. So I'll use all the default markers, default colors and everything, but I'll just make it a size of 100. So how did I come up with this magical number 100? I mean, this is just by hit and trial. You can try, small numbers and see what it gives you. So okay, so now we have this scatter plot which has the sepal length in the x-axis and the petal length in the y-axis, and we should make this more informative, right? So we will use the x label to say that this is the sepal length, and we will say y label, this is the petal length. We'll say that the title of this plot of sepal length versus petal length from the iris, right? Cool. See if there are any questions. So there is a question from in the chat box. I have got this no handles with labels found to put in legend. Before the matplotlib, I have got this print no handles with labels found to put in legend y. Um, I'm not sure if I understand the question. Maybe you can copy and paste your code, the part of the code where you are defining the legend. So I'm gonna keep this on the screen just for everybody to see, and for you to also check your code. So if you write these lines of code, it should not give you any error. So and we can check that. Let's actually see what's happening in here. All right, so I have a code to try to debug here. Iris is lowercase. Yeah, it depends on how you're defining your variable, right? So in my case, I have defined variable as small iris. If you're following this, then you have an error in the way you are calling the variable inside the dot. I have defined like this. Okay, well, if you have, then we will just change it into our variable, and we'll see what's happening with the code, right? So okay, so plot iris sepal length, plot iris sepal length. Well, I don't need two of these lines. I'll just delete this. Right, sepal length, petal length, X label, Y label, title, and legend. So one thing that's missing is, I had mentioned that we would need a label for each of these plots, right? Or else the legend might get confused. It might actually give you an error. So in fact, let me actually try this without defining the labels. Let's see what error comes. So the error is not, this is not an error, this is actually a warning. So no handles with labels found to put in legend. So now I think I understand why it's coming. So that's because you haven't defined the label in each of this plot, right? So you'd have to define label as first plot and label equal to second plot. So that's how we let the legend know that, it has to plot the legend with these two names. I think this should actually do it for you. Perfect. All right. So these are all the small details, but very important question. And I hope we are, sometimes by repetition also we learn it better. So, and yeah, no, keep the questions coming. Thank you. So let's see if there are some more questions. I've defined like this. Okay, scatter plot doesn't seem to support legend. Let's try that, right? So I'll just delete this. Okay, so let's see. So let's say we are plotting the iris sepal length versus petal length, and we are also plotting the sepal, what is the other thing? Width, I think, right? Yeah. Sepal width versus petal width. Right. So let's see what it gives me. So it gives me two different plots. It has cycled through the color scheme. The only thing that I need to do is possibly a label, a first plot, and label of second plot, and I'll put a legend. So it does support the legend. I hope, David, that answers your question. Yep, that is true. Legend works with label. So there's another question, colon K and R, what do you mean in the plot command? So yeah, so the first character in here is the type of plot that you're plotting, right? So this can be, if I have a dash, this means that it's a continuous line. This is by default, is what being used. If you have a colon, it's plotting this kind of a plot. If you have, I don't know, a caret symbol, then it will plot it as a caret. And likewise, right? So yeah, so that's actually the type of symbol, and the second one is the color, right? So the K is for black, R is for red. And I think that's yeah, so Natalie actually answered that, so that, thank you, Natalie. And again, I'll remind you guys that do look at the help functions sometimes, because it's once you start using all these functions day in day out, it's good to know some of these keywords, right? So again, a revision for you guys, you can use the help command and put the function name inside, and that'll actually tell you what these function does. And it has a lot of things inside, as you can see. It's a pretty exhaustive one. And in here, you will also find things like what is the line style, right? So you see, these are all the line styles that's being used. And then it should also explain you what the different line styles mean. So these are the different characters, so what they mean: point, comma, circle, and whatnot, horizontal line, vertical line, dash dot line, then the different colors. Right? So blue, green, red, cyan, magenta, yellow, black, and white. All right, cool. So okay, so now that we have a scatter plot. Now another question that might come in is, you wanted to change the size of the plot, right? So it's too small. So can you scroll a bit above? Yeah, is this fine? Yeah, so we'll now try to do a plot that has a bigger size. Okay, which has you will specify the size. So we'll try to change the size of a plot. Okay, sorry, move this down. So changing the size of a plot. So to do that, and again, this is one of the way, there are many ways of doing this, but inside matplotlib pyplot, we have a function called figure, and in using that figure function, you can actually specify the figure size very, very nicely. And also you can specify if you're doing scientific publications, some of these publications require you to have a specific DPI, which is actually the quality uh, of the plot. So you can also specify all of that, and some other aspects as well. So we will import this function called a figure from matplotlib.pyplot. So we'll say from matplotlib.pyplot import figure. Right, so this is importing the figure function in here. So once we import this, we'll use that function, we'll call it figure. And again, this is maybe it might seem a little bit absurd for you, but this is something that you will get used to. I mean, you can copy paste this line of code everywhere, right? Once you have a standard set of commands for plotting, you can just use them all the time. So we'll use this line. So num equal to none. So we are not specifying any number of figures in here, but we are going to specify the figure size, which is using the keyword fig size. And I specified this, and I always get confused at what units these numbers are, but again, I use it using, so if I want to make it bigger, so I think this is, the first one is the length and the second one is the width. Don't ask me what these number units are. I'll let you guys figure that out. But all right, so once I mention the figure size, I'll mention the DPI as well. So I'll keep it at 80. And I can do other stuffs, like the face color of the plot should be in white and the edge color of the plot should be in black. So these are all related to aesthetics for a figure, right? And then I'm going to copy and paste the same lines of code that we had before, right? So that we see the difference as well. So the only thing that I wanted to show you guys is the figure size uh, that is being specified using the figure function. So let's see what this plot does. So now you can see that it's a much bigger plot with a better quality and whatnot. So, and you can increase the DPIs to a much higher number. Like for example, you can go to 120. It'll just make the file size. If you export these, it'll make it even bigger. But it's a much clearer plot, like you can see here. And I'm not a specialist, I'll have to admit, in all these numbers. So you guys might actually help me. So let's see some more questions in here. $8.12 DPI means, okay, so let's Google it, right? Learn together. DPI meaning dots per inch. It's a measure of the resolution of a printed document or digital scan. just tells you about the quality of the plot. That's how I remember it. Could you paste that last setup? Okay, yeah. Thank you, Natalie, for doing that. So I guess we are right at the hour. Maybe we can take a quick 5-minute break here, Michael. If you guys have any questions till what we have covered till now, please feel free to
Yes,
ask.
Vishal, I think it's a good time for a 5 minutes break.
Cool. Awesome.
Can you please scroll back up on your code? I want to check something on the syntactic figure.
Okay, sure. Is this good?
Yeah, that's fine. Thanks.
Okay, sure.
So Vishal, maybe we'll make it a 10-minute break and we're back at 3:10.
Okay, all right, sounds good. And I see there's a comment from Natalie, right? Not sure what the face color and edge color are doing, right? Maybe it's worth changing the color to red, and you would know. I think maybe it's doing something. I'm not sure. I think it mainly works when you're exporting them, I guess. Not very sure, but yeah. So like for example, the face color, you can see that's the background for the plots, and the edge color also has something. I don't think you have the edges visible in the inline plot, but I think it plots the edge for you in the color that you specify. And this is much more, you know, important when you are trying to export the files. All right, cool. I'll take a quick bio break and I'll be back with you guys.
So let's all be back at 3:10, so 9 minutes from now.
Perfect. Thank you, Michael.
Thank you.
All right, it's 10 past the hour. I think we can resume. Michael?
Yeah, yes, for sure.
Okay, all right, perfect. Hopefully you guys can still see my screen and hear me good. So I was just reading the chats as we were taking a break. So I guess Sudha had posted something on the plot, and I was just looking at what this face color and age color does. And I didn't really see a difference in the edge color, but the face color is quite evident, right? It's the background of the plot. The edge color, as the help file says, is the border color, the color of the border for the figures. And I thought that this might be also a place where we could actually try saving the plots that we have, right? So maybe we can try saving a plot in, uh, let's say in the JPEG format or something like that, saving a plot into a file. So let's see. So the way we do it is we use the PLT function and then we say save fig, right? So that's the function that we have. Again, this function also has like, a bunch of different um keywords and stuffs like that, but I'm going to go with the default one. So the default one is you need to just specify the name of the file, right? So we'll say test figure dot, let's say jpg, and I need to also, you know copy and paste these lines of code so that it knows what it needs to save, right? I'll put this in here, and then I'll say plt.save file. So hopefully it did save. So now the question is, where did it save? So in order to do that, let's look at the browser here, right? So here now you can see there's this file called test underscore figure, and you can download this file right onto your computer. Or this, you can also specify the location where you want to output your file, and then that's it. It should show up as what you have in your plotting. This is an external file which got written out of this, and then you can use this. So I think this face color and edge color is again for display. If you want to use those for saving the file, you can actually go into this save figure format and specify a lot of those details. In fact, this is also a good time when we look at what this save fig has inside it. So let's see. So we have the DPI. This is a very important one. You have the face color and the edge color here as well. You can specify the orientation. You can specify what kind of paper size you need. The bounding box inches, so how tight you want your white spaces to be, and so on and so forth. There are a bunch of keywords. It's pretty robust, I would say, and I have used it to get figures as per publication quality, so it is pretty good. You can rely on this. All right, hopefully you guys found this useful. Now let's go into more details for this. So we had plotted using the scatter plot with two different plots as well. They had different color. We had introduced the legend to it. Now we'll do it in a more careful way, where we say that you know um, we would plot the colors. The third axis will be the color, and it will be colored based on the species type. So remember, we had three different species in the data frame for iris. We had the setosa, we had versicolor, and we have virginica. So we would like to plot the petal length versus sepal length based on these different species, right? That's kind of a useful way of visualizing things. So let me see if there is a question. Yeah, so Sudha, to answer your question, we are not getting the face color and edge color in the saved figure. That's because the saved figure by itself has two keywords, the face color and edge color. I think if you specify them, you might actually see the face color and edge color in the saved figure. Yeah, and I think that was what Natalie was also referring to. Good. All right, so now let's add colors to the scatter plot. Add colors to the scatter plot. And here we would be plotting pet sepal length versus petal length with species type as color, right? So, all right, so let's first make a dictionary of the species type, and let's add, different discrete values to each of these species type. So what we will do, and this is again an operation that we are doing on a dictionary using, or rather we are doing on a data frame using dictionaries. So again, this should be a kind of a revision for you guys. We're trying to bring some of the concepts that you learned before. So we will specify a species dictionary. I'll call it species underscore DICT. Remember the dictionaries, we define them using curly braces. We will say the key is setosa, and with a colon, we assign the value 1, right? So this is the format for dictionary. You guys should uh, this should ring a bell for all you guys. So we have setosa as 1. We will specify the second one, which is versicolor. I'll specify this as 2. And the third one, which is virginica, as right. So that's my dictionary. And now I'll do an operation on the iris data frame. So I'll add a column inside the iris data frame. So remember how we define a new column, we call the data frame and then we specify the column name. So I'll say species underscore ID. Okay. And then what we will do is we will call in the species column in here in the iris data frame. And then we will say replace. For this new column, what we will do is we'll replace the the species type based on this key and the values that's been defined here. So it's a one liner again. We will say replace it with species underscore dictionary. Right, so this replace function takes in a dictionary, and what it does, it creates a new column called the species ID. It takes the species, it looks at the dictionary, it finds these keywords in there, and then replaces it with the values. Right, so let's hope and see that this works. So okay, so yeah, so it did do what we intended it to do. So we have the setosa as the species ID 1, and then the virginica as species ID 3. Yeah, that's the beauty of pandas and data frames, that you can do such a complicated thing in one line. So okay, so now that we have this new column with species ID, we will try to use this as the color in our in our plot. So let's add a new cell in here. So I'll again, this is from previous lines, so we'll use the scatter function. We will specify the x-axis as before. This is the sepal length. We will specify the y-axis as petal length, right? And then what we will do is we will call in the keyword C, which is actually the color. C is equal to, and we will say that the color would be defined by this species ID that we just defined in our data frame. This is the new column that we defined, right? So, and then what we will do is we will make this a little bit informative. Let's say X label is sepal length, y label as petal length, and then we will say the title sepal length versus petal length, the iris data set, colored with species type. Right? That's informative enough, and then let's see what it gives us. So yeah, so this is what we get. So we have the three different species colored with their different colors. Now, a better plot for this would be to have this with legends, and um, we should be able to do all of this without even defining a new column which defines a species ID and stuff like that. And that is where I wanted to show you the power of Seaborn. So Seaborn is a package which I touched upon briefly in the previous class. So it's a separate package that also does a lot of plotting. So let's see, Seaborn package. So let's go into that website. So it's a Python data visualization library based on Matplotlib, but it provides a high-level interface for drawing attractive and informative statistics. So this is very, very popular among statisticians because they have incorporated inside Seaborn a lot of functionalities from the R plotting libraries and have made things that you do day in day out in statistical analysis like really easy to implement and get outputs of. So another really good package to keep in mind when you're using plotting, and you might actually come across a lot of codes in Google which uses the Seaborn library. It's getting very, very popular. So all right, so now we will plot the same plot as before using Seaborn package, right? So, and the first thing that we do, this should be something that should come up to you right away. So we import the Seaborn package, right? So we import Seaborn as SNS. That's another standard way of doing it. All right, so now what we will do is we will use a function from the Seaborn package. Can you scroll to the first line, previous code? Sure. So here we're using the scatter function with x and y variables, and the third variable, which is defined as color, c equal to, maybe this is a thing that's worth mentioning, that actually tells you that in the scatter plot, the color axis will be defined by the species ID. Hopefully that's clear. Okay, so yeah, so this is the one liner to add a new column with this dictionary that we specified, right? So and then replace in this column, new column, every species with the keyword and its corresponding values. So this is what we got out of it, right? Okay, hopefully that's clear. I will go on with the Seaborn package. I have imported Seaborn, and now what I'll do is, let me actually insert another line of code or cell of code here. I'll say SNS. That's the Seaborn package. And inside this, you can see there's like bunch of things. Some of the really cool stuffs like distribution plots and all of these are something. This is amazing. You can do kernel density estimations and fit your probability functions on histograms and stuff like that, which are not super trivial to do actually in using standard packages. But anyhow, so what we will use here is what is called the LM plot, right? So that's a function from the SNS library. And in here, I'll put also, so to do this, so SNS, so there are some key things that you need to make sure that you do. So you need to make sure that you define an index in your data frame with the ID numbers for each of this. So I'll show you what I mean by this. So I'll insert a new column, which is the column, and this essentially is all the indices uh, for the for the iris database. So these are essentially the columns. So let's actually try to see what this does, right? So, and this is specific again to the SNS package, and if you start using SNS package, you would see that this is something that is done all the time. So they use the ID as the x-axis for all these you know all these plots. I have a disconnection from here. That's okay. I can open a new notebook. All I need to do is to import few packages. These two lines. Import iris database. That should do it. And then I need to import the Seaborn package. Right, so let's try and resume what we were doing. So we were defining the ID column to the indexing. And again, so so this is where, so yeah, so I'll tell you what I'm trying to do in here. So what we are trying to do is, in the first example that I would show you, I will plot the sepal length, let's say, with the index values. Okay, so this was, remember, the first plot that we showed before. So this was the simple line plot using the matplotlib. So where you specify just one axis, one variable, and it knew that the other variable, the x-axis, is essentially the row numbers, right? But Seaborn doesn't realize this by itself. So we need to explicitly create a indexing column, and you would see what this does. So we are creating a new column and calling it ID, and we are just accessing the indices for the different rows, right? So as a result of this, what you have is, you have a separate column in your iris database or data frame, which has the index numbers that you could see when you visualize the iris as a separate column. So, and you need this because in Seaborn, the way it works is that you have to specify an X and Y. It doesn't work with just one input. That is how it works. So hopefully that answers that question. All right, so now that we have an ID column, this is essentially the index column. So what I'll do first is I'll try to plot the same as the 1D plot using matplotlib dot pyplot, right? And group this by um, the species. I think there are some errors. So Natalie, I think I did clear your part. So Sudha, you're getting an error in your code. So let me actually bring your code in and see what we can spot out of this. before we go into Seaborn. All right, add color. So I do see that the dictionary is fine. Species ID dot replace. So I hope these two lines should work fine. So let's actually see if this works or not. Let's see if the iris database data frame is having the species ID. Yes, it does. Oh, so there is a problem. So it didn't replace these ones, right? So then that's because it's Virginica, right? That should do it for us. Yeah. And the reason why I'm copy and pasting all your codes and here doing the debugging here is I hope you guys realize that this is how we debug. I mean, there's no rocket science behind this. So it's plain and simple. You just execute lines, you look at the outputs, and that's why Jupyter notebooks and Colab notebooks have become so popular, because you can see the outputs without doing much changes, right? So it's all in line. So yeah, so that's how we do the debugging. Yeah, but that's the error. Hopefully that resolves the problem for you. All right, so going back to the 1D plot using Seaborn, not the same as a 1D plot using this group this by species ID using Seaborn package. All right, so in here, what I'll do is first of all, I'll call the function called lmplot. So this is what gives you the line, like the kind of the 1D plot. And here we'll use the x-axis as our ID and the y-axis as our species or sepal length, right? So how we define this is essentially we say x is equal to the column name ID, right? So remember we have this column name ID. So that's our x-axis. The y-axis is again our column name, let's say sepal underscore length. And because this works so nicely with the data frames, so you can say data is equal to iris. Okay, so this is how it used to also, if you guys have used R, this is how plotting is also done in R. A lot of packages in R uses the same type of thing. Now, the other keyword that we need to give is hue. So hue is essentially defining the color, right? So we will put the color as species. So we didn't need to define the species ID, right? So we can just use the species. It knows that this is a discrete variable and it does the classification by itself. It would assign the classes by itself, and you don't that one line of replacing them with the dictionary values, right? And also by default it fits a regression and whatnot with it, so we'll not want that at this point. So this is a statistical package, so they would put in all sorts of statistical details in here. So let's see what it does with this guy. So all right, so it did plot ID versus sepal length, and it put this legend by itself, and it said that the blue dots are setosa, the orange dots are versicolor, and this is virginica. So, and again, I think if you set the legend for the LM plot to be false, and then actually use matplotlib's pyplot's legend function, this actually should go as a better way. So it brings it inside and it puts a box and doesn't have the thing. So but the idea here is that the Seaborn package actually helps you do a lot of these things in a much nicer and easier way. Now you might say that, well, it's not something that you could not do in matplotlib, so then I mean you don't have to go into Seaborn package, but yeah, this is something that I did want to show you guys. And in fact, I'd like to show you with the regression being set at true. So we'll try to fit a linear regression function to this plot. So it's amazing how it does it. So you haven't specified anything. You just said that, the regression, set it as true. That's it. It plotted the regressions. It also plotted the uncertainty range for that regression for all of those. And it did it by each group. So to do this plot using matplotlib, you would have to write some lines of code. But to do this using Seaborn, you just had to change one keyword. That's about it. It's very impressive. So let's see if there are any questions. Yeah, so Philip mentioned that there is a legend out keyword, right? So let's actually try that. And we say that this is equal to false, and we don't need the plot.legend. So yeah, this brings the thing to inside. So that is a true statement, Philip. Thank you. And again, I'd encourage you guys to look at this this help for this function, and you would see that how it does all of this. So it does a very rigorous statistical fitting of the plot. It does the whole linear linear regression and whatnot with this LM plot. So let's actually try and see what it does in a nutshell. So it's a part of the Seaborn.regression package, and it helps to give a LM plot for that. And then there are different keywords for it. There are different ways you can specify the color and the markers. Legend out. This is what Philip mentioned. Legend will be drawn outside the plot on the center right. You can call the estimators. It has the standard deviation, the size of the confidence interval plotted. You can take it off if you want, if you do not want a confidence interval plotted. And yeah, if you want to, instead of doing a linear regression, you want to do a logistic regression, you can just use the keyword logistics and then make it true. So if you wanted to do a transformation to your data, instead of doing y equal to mx plus c, you do a y linear regression with log x, then you just set this keyword and stuffs like that. So beautiful, like it's possibly like all the things that you can think about using an LM plot in R, all of those are defined in here. All right, so few other things that I will quickly show you. So this is a quick show of the power of the Seaborn package. I'll not go deep into this. Let's do some more statistical plots, things that people like to see when they're doing statistical analysis. So one of the easy and most robust way of looking at data is to plot the histogram. So plotting histograms of data. So we'll try to plot the histogram of petal length, let's say, right? So again, we will use matplotlib pyplot module. We'll say plt.hist. That's it. That's all you need to make a histogram. And then inside it, the required variable is the data that you're trying to get the histogram of. So I'll say iris and petal underscore length. And you can also specify the number of bins, because that's something that you would like to control. But in this case, there is a way of making the code analyze the data and divide it into a reasonable amount of bins. So in order to do that, you can just use bins equal to auto. And what it'll do is, so again, this array is essentially, because we're using the PLT function, it does give you the output of the histograms, the bin mid value and the number of data points in each bin. So you can either suppress this by outputting this in a particular variable, hist1, or I'll show you another thing. So if you want to plot a couple of things in the same line, so a way to do to show a plot is using plt.show, right? So that'll suppress the thing. And again, why will this be useful? So let's say you wanted to plot the histogram for petal length and the petal width, right? So let's say we wanted to plot both these things, and we would comment out the plot.show. So what it'll do, and you guys should know this, that it'll try to plot one over another, right? Because we did the similar thing in the 1D plot. We plotted one over another, but you wanted them to be in separate plots, right? So let's say if you do, and a way to do that is to use the plot.show in each of this. So then you will get two different. So this plot.show would exit this plot and then will show the plot before going to the next line. Right. So this is one of the way to plot histogram. The histogram plots with the Seaborn functions as well, Seaborn library as well, and in Seaborn you have a way to actually fit the probability distribution function to the histogram. And this might sound very trivial, but it is actually not easy if you do it in a rigorous way. But SNS or the Seaborn does this using the distribution plot. Okay, so that's the function. So there's a question about, could you do the suppression of the array line? Yes, you could. Either you use the plt.show after your plot, or you output this histogram into another variable. Let's say you can say histogram1 is equal to this. Then you should not get any array as the output. All right, so I was talking about the Seaborn distribution plot. So let's say Seaborn probability distribution. Right. So what I'll do is I'll plot the petal length. So I'll say iris petal length. And now, as you saw before, Seaborn doesn't give you just a plot; it does something more. So it'll give you a cumulative distribution function, or rather probability distribution function fitted to you. You can also change this PDF into a CDF and plot that as well using different keywords. And I mean, it's fantastic the way they designed it. You just have one line of code and you get, like, the access labels and everything plotted off, like with the transparency of the bins and whatnot. So pretty cool. Again, you can suppress this by either saying plot.show or outputting it to a variable. So it says a warning. This you cannot suppress. Dist plot is a deprecated function and will be removed in a future release. Okay, that's interesting. So what are they? Please adapt your code to either dist plot, bigger level function with similar flexibility, or hist plot. Okay, that's cool. Good to know. I might have to change some of my codes. Let's see. Okay, so this is hist plot, and then they have the dist plot. So how do I get the probability distribution function? I'm sure this plot has something inside it that would give me the distribution function. So let's see. Color, hue, color, kind, histogram. Interesting. Oh, kind. Kind is hist, KDE, or ECDF. So what does this do? Good question. What is the difference between the hist plot and dis plot? I don't know. Let's check it out, right? What do they seem similar? Yeah, they do. Let's see. So this is the function provides access to several approaches for visualizing the univariate or bivariate distribution of data. Okay. You know what? I'm sure somebody must have had this question. Difference between his plot and this plot. So I think the distribution plot actually gives you a way to also plot the distribution and not just the histogram. So histogram, is just binning the data and just counting how many are there in the bins. But distribution plot, I think, gives you the additional capacity to make the distribution. That should be the difference. But yeah, maybe we can try it out tomorrow during the discussions as well. Like, what's the difference? Maybe you guys can come up with a problem and we can and try to see and figure it out together, how to do this. But I do want to check the kind in here. So kind is, let's say they have KDE, kernel density estimates. I think this will be just the probability distribution function. Then they have the hist here, which is the histogram for sure. That's the default. And then they have the ECDF. That should be the cumulative distribution function. So that's the cumulative. So I see what they're doing here. So they are making us actually write 2 lines of code to get the plot that we could get in dist, I think, if I'm not mistaken. So let's try this. KDE. Okay, no. What if I want to plot both together? Yeah, I will have to figure that out together. Maybe we can do that tomorrow. Sorry to get distracted. So see, this is how things are changing pretty rapidly in this field. So you need to. So I have to change some of my codes to make sure that I suppress these warnings. But yeah, for now let's just move ahead with all of this. All right. So okay, what were we doing? We were doing the distribution plot. So let me go back to dist for now and just live with the warning. What was it? Oh, there's no keyword called kind. Sure. Let's do it. Okay, cool. We got what we wanted. Right. So now let's go into more bar plots and see what we can do with the histogram and the outputs of histogram. So remember, when we plotted the histogram, we are getting all this array as output, which we had to suppress. Some people asked, but those outputs are very, very useful. So we can use the histogram plot to make different bar plots. So let's put the title as bar plots, and we would use the plt.hist function, make bar plots. Right? Okay, so what we will do here, we will do the same thing as before, plt.hist, and we will mention the petal length. That's our input. We'll keep the bins as 0. No, bins as auto, sorry. And we will output this, and this output is actually not just one output. There are 3 different outputs from here. So what we'll do is we'll say that the first variable is n. So this is the right hand side of the expression, right? And on the left hand side, I'm trying to assign it to variables. So I'll say n, then bins, and then there is another variable which is the patches. So I'll not need that. So I just specify it using an underscore. Okay. So these are the three outputs that you get from the plt.hist. And let's check it out. So we'll execute this, and we now have the n bins and the underscore. So let's see what n is. So it's an array which actually tells you how many data points are there in each of these bins. Okay. And what does bins have? So it has the midpoint of all this. I think it has the midpoint plus the starting and the ending points for all these bins, right? So we can use that to create some nice and interesting bar plot. So let's say we want to compute the centers of these bins and put them in the right place in the x-axis, right? So we want to not label it by where it starts and where it stops. We want to label it with, you know, the bin centers, let's say. Okay, so can be um, a thing that you want in your case, right? So what we'll have to do is we'll have to compute the bin centers and put them in the right place on the x-axis. So the problem here is that, you know, instead of putting this numbers in this way, we will just put them as the center of the bins, right? So that's what we're trying to address here, and we'll just try to make the x-axis such that it has the bin centers. All right, so what we'll do is we'll calculate this thing called bins or bin centers. And what we will do is we will use the bins variable that we had. So we'll just compute the center point. That's like the average of the you know, the bin endpoints, right? So what we'll do is, so the bins has the first, like I said, the first one is like, you know, the starting, and the last one is the ending. So we'll start from the second index, which means we'll start from 1. We'll go till the end, right? And then we will take the next point and we'll go to 1 minus, right? So we'll go to end minus 1, right? So this, what it is doing, it is taking the second point and the third point and adding them together, and we'll have to do the average of both. Again, a very neat way of writing one line codes. These are some questions that come into interviews as well. How do you make this code, like write it in one line or things like that? So yeah, so this is what would calculate the bin center, and we can actually check what it calculates. So let's just output bin center. So it just gives you the values of the bins, of the center of the bins. So we'll now use this to, you know, plot the histogram again, and now we'll not use the hist function. We'll use what is called the bar function, because this is like a bar plot, right? So then we'll say that the x-axis is the bin center, right? And the y-axis is the count, right? Which is n that we you know, got from here. So these are the count of the number of values in each bins. So this is the bin center and this is the value. We can also specify the width in the bar plot. We'll say that width is equal to 2. And we can also specify the color of the bar plot. So let's say the color we specify it as gray. Okay. So yeah, so now we have it in terms of, you know, all the bin centers. I don't know, it's probably truncating the values based on the decimal points, but it is putting the labels in the place that it should put. And you can you know, make this anything else that you want, and you can also specify where exactly it is plotting and whatnot. So but this is truncating it according to the floating points to integers as we plot it in the legend. And this bar plot also has the x label, y label, and things like that. Now we can also add some more information to this bar plot. We can, let's say, highlight the median value from this, right? So if we didn't know about Seaborn, we might have to do it ourselves in the in this bar plot. So what we'll try to do now is add a bit more information to the bar plot, right? And we will, for example, add or compute the bin which contains the median value, right? And we will highlight it. Okay, so now again, remember from your NumPy classes, we could use the percentile function to get the 58th percentile, which is the median value, right? So we'll use the np.percentile. That's a function that we use to calculate the mean. We'll say iris petal length, and we will say that, you know, compute the 58th percentile. So that's the median value, P50. Okay. Now what we will do is we will try to find out the index of this array that we created, the bin center, where we have the P58 value, right? So we will say median bin is equal to numpy.argument minimum. Again, some you know, one-liner codes that you might start to be more, you know, used to. So we'll say numpy argument, and I'm taking the absolute value of the difference in the bin center and this P50 value. So what did I do here? So what I did was I found this median value. Now I'm taking a difference in between the bin center that I created before and this P50 value. And I'm taking the absolute value of that. And wherever this is minimum, right, that is where the P50 value is closest to this bin center value, right? So that's a way you find the index of the particular bin that is closest to the P50 value. Yeah, hopefully that makes sense. All right, so now what we'll say is we'll define colors and mean. I'm not sure if we need this. Okay, so let's say we define this colors numpy array and just name it lime green. So this is defining the color of that particular bin, and then we will use the same function as before, plot that bar, and we'll say bin underscore center, number, the counts, the width will be the same as 2, and in color we will say it as colors. Okay, and let's say plot that. Let's see if this works. So colors is not defined. Okay, so maybe we'll have to define the colors for all of this. This. Oh, sorry. No, it's because you know, I have to define this. So yeah, this is where it gets a little bit tricky, and yeah, maybe we'll have to debug this for now. I think we are just at time for the session. Maybe this is a good point where we can pick up tomorrow and, you know, first debug this, what's going on. Let's try to solve and highlight the bin which actually corresponds to the P50 value. I think we are very close. We just need to mention the colors according to what we want, and that should do it. But yeah, I guess I think this is a good point to stop here, Michael.
Hi, Vishal. Thank you so much, man, for walking us through this. Really great. I've learned a lot, you know, Seaborn, Matplotlib, a lot of things to do with these packages, actually, from data exploratory to analysis and also data reporting. You know, this is really great. A lot of materials that you've covered in such a short time. So I want to encourage everybody to play with this a little more, you know, look at some of those documentation that on the Matplotlib and try to get some data sets to play with it. It's very powerful. You're going to use it for a lot of, you know, a lot of analysis and a lot of stuff, regardless of where you are working or what you plan to do. So spend some more time to play with it and come tomorrow with questions, and we can have it during the discussion. And also, if you have questions on the projects, you can bring it up tomorrow as well, so we can address that. I also want to encourage us to use the Slack channel that we've created for interaction. So as you walk through your homework, if you have questions, reach out and you have people that can provide answers. I want it to be live. Thanks to Philip for some of the links that he shared today in the Slack channel. So I encourage us to use that some more as we practice this. If you find something online, some more documentation, share it with the group and let everybody just continue to work through that together. But thanks once again, it's 4 o'clock already. Thanks to Vishal for such a great lecture. I learned a lot myself. I'm going to actually play with this tonight as well for fun. So thanks everybody.
Yep, and let's go home with this problem with where we want to highlight the median bean. I'd open it up with this tomorrow, and maybe you guys can find a solution.
We'll figure it out before tomorrow.
Yeah,
Yeah,
but I'll try as well. Yes.
yeah, I'll send out the course video for you guys. I know it's a lot of materials, but we record this video, so I'll send it out so that when you revise this, you can use the video as a guide. And I'll also send the collab notebook from today so that you can actually follow along. I know it's a lot of materials, and maybe some of you may not have caught everything into this class. So I'll be sharing those to you. But thanks a lot. Thanks for everybody. Thanks for the continuous active participation. We're kind of getting close, and I hope we're learning a lot that we can apply. All right, with that, I think we can call it a day. 4:01. Have a good rest of your day, and we look forward to seeing you guys tomorrow.
Thanks, everyone. Bye.